Hello, good morning, everybody. Thank you for being with us today at this 5th session of Air Quality Community of Practice, and this is coordinated by WRI Mexico. My name is Ana Cecilia Perales, and I will be the leader of today's session. We have the name today of our session is Generation and Visualization of Air Quality Data, and our idea is to go deeper into data visualization through a resource watch and a map building. And also we are going to share information about challenges regarding these visualization platforms. And as it is for every session, we are going to start by listening to 2 key notes. Today we have Kristine Lister, who is an analyst of investigation, who will tell us about the Resource Watch platform. And then we're going to have Nancy Sánchez, who is product specialist for Resource Watch, and she will tell us about data visualization through MapBuilder and how it integrates to Resource Watch. And we are going to close this first session with a Q&A session directed by WR specialist Sergio Baldit. And then our next session from Africa, we're going to listen to some of their experiences and challenges in regards to visualization platforms from Victoria in Uganda, and also from Richard in Uganda. And then we're going to listen to Victoria also. And then at the end of this, we're also going to hold another Q&A session that is going to be led by Dr. Beatriz Cárdenas. So now we are going to have our first keynote speaker. This is going to be Kristine, who is an analyst at Resource Watch. Thank you, Kristine. The floor is yours.
Thank you all for joining us today. I'm joined also by Nancy Sánchez, also on the Resource Watch team within the Data Lab of the World Resource Institute. Today, we'll be talking about air quality data generation and visualization. So our agenda today, I'll be giving an introduction to Resource Watch, which is a data visualization discovery tool from the World Resource Institute, and our collaboration with the Mexico team, particularly in, the air quality team, particularly in the Mexico office from the World Resource Institute. So I'll give an introduction to Resource Watch, then an overview of the air quality data on Resource Watch, data processing that's gone into these data sets, and direct links and assets to the underlying data that we show on Resource Watch. Nancy will then go into MapBuilder, which is a new collaboration from Resource Watch that allows you to create interactive web maps from your data and data from Resource Watch. So first into Resource Watch and the air quality data that we do have. Resource Watch is an open data platform where you can discover hundreds of data sets that cover topics such as food, forests, water, energy, climate, cities, ocean, and air quality. Resource Watch is a data visualization and discovery tool, like I said. I'll be going a little more into the platform in the next slide, but we curate data from trusted data providers such as NASA, NOAA, the World Bank, and other universities and research organizations like WRI. We pull together metadata and visualize the data on Resource Watch, and we store our data in third-party systems that I'll go into later in this presentation. So first, as a quick overview of how you navigate Resource Watch, when you go to the home page, you get to that Explore button first, and when you click on it, you get to our Explore page here, where you can see all of our data sets. On the left, we have various tabs. You can navigate to subsections of the data sets, or you can use our search function like I am right now. Here I searched for nitrogen, which will search for that word in the title. You can scroll down to see the results of your search, and I just clicked on one of the data sets that actually I'll be talking about in this presentation later. You can drag around the map to pan and zoom to different levels. And on the left here, we have metadata for the data set. We provide an overview and a methodology of the data set, as well as information on the data layers that are shown on the map. You can navigate through the data layers. For this one, it's a time slider where we're jumping through different data layers that are available in the data set. And for each one, when you click through, it updates the layer description on the left here. So now this was recorded a couple days ago, but it showed the current day's nitrogen dioxide concentration. We also provide you links to learn more about the data from the data provider. Like I said, this was a NASA data set, and we provide you links to directly learn more about the data set and to download data from the provider. We also have a function to share the view that you are currently looking at from the map in that tiny URL that I just showed, and the link for an iframe, which is an HTML object that you can embed in your own website. So the link to this presentation will be provided so you can watch this again, but we hope the website is pretty easy to navigate. And if you have any questions, you can reach out to myself, Nancy, or Sergio. So then on the air quality data sets that we have on Resource Watch, we have a number of them, and the air quality team from WRI has been super helpful in helping us curate these data sets. So I'll go into each of them, but we feature near real-time station level measurements, projected station level measurements, near real-time satellite derived measurements, and projected satellite derived measurements that show the projected air quality for the next couple of days. The first one I'll talk about is the station level measurements from the OpenAQ project that I'm sure many of you are familiar with. We show all the available concentrations from OpenAQ, which include PM 2.5, PM 10, sulfur dioxide, nitrogen dioxide, ozone, carbon monoxide, and black carbon. Like I said, this is from the OpenAQ data set, which aggregates station level measurements from governments and scientific stations. Then they have this open source platform, kind of similar like Resource Watch, but for these air quality concentrations. We on Resource Watch show the latest 24-hour concentrations, which we update daily. And we also show the station locations that do not have measurements in the last 24 hours. So you'll see them in kind of faded circles. We have the best kind of coverage in the United States, Europe, and India, with sparser coverage in South America and Africa, where these stations are available. And you can read more about the metadata in any of these links. They link directly to the particular concentration on Resource Watch. Next, we have projected station level measurements that show the forecasted concentration for the following 5 days. This comes from the City AQ dataset, which is a collaboration between the World Resource Institute and NASA. The forecast concentrations come from the NASA GeoCF dataset, which we also feature on Resource Watch, and I'll get into in a couple slides here. But the WRI team worked with the NASA team to downscale those projections that are available at a coarser spatial resolution, a pixel level map. So the WRI team helped to localize these forecasts to the station level using a machine learning algorithm. So on Resource Watch, we show the 24-hour concentration forecasted for the next 5 days. This is updated daily and is only available for cities that are participating in the City AQ project. And we additionally also show the stations that do not have updated forecasts, so you can see when they're missing. And the available concentrations are PM 2.5, nitrogen dioxide, and ozone for this data set. And again, if you follow any of these links, you can read more about the data set within our metadata. Next, going into our satellite-derived air quality data sets. These are available as raster or pixel level data sets and have global coverage, but often a coarser spatial resolution than the station level measurements. So our first one shows a monthly average concentration for the past month from the Tropomi satellite, which shows the concentration at the troposphere. This is updated monthly and has global coverage at 3.5 by 5.5 kilometer resolution. This is our highest spatial resolution satellite derived air quality data set that shows historical data and is available for nitrogen dioxide, carbon monoxide, aerosol index, and ozone. Next, we have the NASA GOES CF or GeoCF data set that is the projections that are shown in the downscaled city AQ data set. This data set has the forecasted daily concentration for the following 5 days, including the current day's observed concentration. So the compounds that are available are nitrogen dioxide, carbon monoxide, aerosol index, and ozone. So like I said, yeah, we show the current day concentration and the forecasted for the following 5 days. This is again updated daily and has a lower resolution of 25 by 25 kilometers. But you get the next 5 days, which is great. And for our final air quality data set that's available on Resource Watch, we have the the whole atmospheric community climate model, or WACCM. This one has a couple more available compounds, including sulfur dioxide, PM2.5, black carbon, ozone, nitrogen dioxide, and carbon monoxide. This one shows only the next day's forecast concentration. It is also updated daily and has a global coverage at a resolution of 1.9 by 2.5 degrees. So this one is our lowest resolution satellite data set that has some more compounds available. So in terms of which ones would we recommend that you use if you are working at the city level, we would go with the open AQ and city AQ data sets that have the highest resolution and are measured on the ground. If you are looking at multiple areas at a time and that do not have as good of station level measurements that you can see in the open AQ data set, you can look at any of these satellite derived products. For historical concentrations, you can look at the Tropomi data set, and for projected level satellite derived concentrations, you can look at the GeoCF and the WACCM models here. And again, all of these links will direct you to the data sets on Resource Watch. To see how we process these data sets, you can go to our GitHub. Links to our GitHub are provided in the visualizing the data set section of the metadata of the Resource Watch after the additional information and the metadata that will link to any other compounds that we have for the data set. When you get to the link on the GitHub, we have them organized in folders with a README file that describes where we got the data, any processing that we did, and links back to the data sets on Resource Watch. You can then go into the contents folder here to get the actual Python script that runs the data. This will include how we download the data from the source provider, any pre-processing that we do to the data set. For many of the air quality ones, we will aggregate the data from either hourly reports from the NASA providers into daily concentrations, or from daily to monthly, like the Tropomi data set. For the city AQ and the open AQ, we pull directly from those data sources. And yeah, we comment all of our code so you can follow along as well. Finally, Resource Watch is a data visualization and metadata system so that you can easily search for, discover, and visualize data. But we actually store our processed data sets in third-party systems. For our vector data, we use Carto, and for our raster data, we use Google Earth Engine. So I'm going to go into how you can directly access the data that we have on Resource Watch. You can find these links also in our GitHub, but it's easiest for if you have the links directly. So I'll be going into them for each of the data sets. For the Carto links, they are just regular URLs, and you get a table, which is great. You can download the data, and these links are permanent and what we directly update. So they will change every day. We only keep so much of the data. So if you want this week's data, you can view that in our Carto tables. but eventually we remove older data. And for our raster data, we use Google Earth Engine, which is an open source kind of like web GIS platform from Google. It can be a little hard for non-technical people, but if you really want to dig into the data, it's available. I definitely recommend using it. Once you get to know it, it's not that hard to use. But I linked to the Get Started page on Earth Engine here, and you'll see how the assets look a little different from the Carto ones. So this presentation will be available after this recording, where you can see all of these links. But for the OpenAQ data sets, here are the links. And like I said, they will be directly available as tables within Carto that you can download either as a shapefile or a CSV. For the city AQ, we also have the station forecasts. These are tagged with both the forecasted date and the date that the forecasts were created. And they're available for each of the different concentrations. Next, we have for our satellite derived data sets, these are now all assets within Earth Engine. So we keep them in image collections. This is kind of like almost the link to the photo album, where each of the data layers that we show on Resource Watch are like the photos in the photo album. So the image collection link stays permanent, but we update new images for each data layer in Resource Watch. For these ones, for the Tropomi one, it's the latest month's concentration. For the rest of them, they're the daily concentrations. So here they are for each of the concentrations from Tropomi, and you can access the latest month's concentrations either by finding the latest image in the collection or by filtering the date. All of our images are also tagged by the date of the coverage of the image. For the NASA GeoCF dataset, this is the one with the 5-day projected air quality concentrations. We have both the historical daily concentration, this is the one that the satellite directly observes, and the modeled 5-day forecast. We keep them in separate image collections with these assets here, very similar to the Tropomi ones. And finally, we have the NASA Wacom satellite derived data as well that shows the next day's concentration for a couple more compounds that are available. So if you have any questions on accessing these data sets or want help getting started with Earth Engine, you can reach out to me after this presentation. So this is wrapping it up for the Resource Watch section, and I'm going to turn it over now to Nancy to talk about MapBuilder, and I will stop sharing my screen here.
Thank you for your kind introduction. Probably that you have seen, this is Kristine is one of the great specialists in terms of data management and all her experience working with air quality and WRI in Mexico, which is so beneficial to all of us. Thank you and good morning, everybody. I want to take advantage of this being a bilingual space, therefore I'm going to speak in Spanish. My name is Nancy. I'm Mexico City based, and I'm a specialist, product specialist for Resource Watch. And recently I have been a specialist also for MapBuilder. And to give you a little more context, and as Kristine has already said, Resource Watch and MapBuilder are part of a data lab, which is an initiative by WRI that includes several initiatives to obtain information through technology and through different platforms. We have Resource Watch and MapBuilder, and also we have other tools that are also aimed to provide these repositories of open source data, so decision makers can make better decisions in terms of sustainability. Well, what is MapBuilder? MapBuilder is a tool very easy to use, that serves to create customized monitoring applications that combine edge spatial data as published by WRI in different disciplines. We know there's air quality, of course, we have land use and many other uses that we are going to refer to later. And what we do is that we bring all data, or we have the opportunity to bring all data to one single place and have the most updated data from WRI families of data according to each user. We know it is very complicated to compile all the data in one single platform and having different information accounts in order to make much more robust data analysis. And this is what we want to offer through this tool. This tool offers different configuration options, and it makes it accessible and customized to different audiences or different types of experts. And it relates, of course, to spatial data. And one of the biggest advantages of this platform is that not necessarily you have to have great technical abilities to and know how to program and know how to use data. But in this case, we have a product that can be easily used at different media, and this is also for information sharing and for the visualization of information. And one of the great advantages of this is that it is not only that we offer one single type of data, or we offer only mathematical data. It is that also that you can cross information in terms of how you can impact or how forests can be impacted based on air quality or land use and so on. And as I said earlier, this is a template that has been preloaded for you to have your own tool, customized tool for your own monitoring applications. And in this case, it is much more focused to the monitoring in a customized manner without really needing to have great experience on technological matters, or that you need to have and rely on a very large infrastructure to view maps. And also another advantage is that preloaded data are going to be very appropriate to your own tool that can be customized in 15 minutes. We have tutorial videos offered to you, and they are available in different languages. And therefore, by doing this, and this is a product that belongs to Bacalab and is constantly under development. And what we aim is
diferentes grupos de interés podamos ir adaptando.
You can learn about the features of this platform, and therefore you're going to have the possibility to direct or send this data to the different stakeholders. Therefore, MapBuilder becomes or turns into a tool that addresses the question of relying on local data, as it would be from a research watch, which is global data. In this case, we're referring to local data that can be added to the data you're offering, and therefore we will have the possibility to have a much more accurate analysis. And basically the way it works is very simple. In this case, we're talking about data coming from the WRI. These are open source, and they rely on different analysis layers, also added to your own data, that in this case can be local measurements or data sets that you have developed yourselves and that you want to cross with global data, or maybe data that comes from protected areas or a community forest that not necessarily are published in other platforms. And also you can use the technology offered by MapBuilder through ArcGIS, which is the platform where where this web application has been created or is constantly created from. And as you can see, when bringing together these two very important needs, you have the possibility to have a very efficient view of your data to proper decision making. Now, the main features in a very general manner And here I'm showing on my screen a view, and here you can see how you can add information and you can customize what this web application is. And also this is a template of the data that have been preloaded. The first version was released in 2015, and prior to turning formally and Data Lab and MapBuilder was only using for Global Forest Watch for different types of forests, and we started working with governments, country governments, as well as civic society associations in order to create a forest world map in order to be able to create the MapBuilder following up platforms to continue to monitor and to project and plan for the follow-up of different protected areas or indigenous areas without needing to invest great amounts of capital to rely on a personal platform. And as I said earlier, this is a very easy to configure platform and totally customized according to the account you're working on and according to your own level of experience in terms of technological platforms. And it also includes integrated analysis tools. When you load this data sets, you can also use analysis tools, and therefore you can address this to your own area of interest, and therefore you can build different measurements and metrics regarding the specific objectives you have. And this can be displayed as an independent tool, or it can be used from the main site for the monitoring, for data inclusion, or to have data offered to your own audiences. This is available in 10 languages. And as I said at the beginning, this tool is constantly adapted to their users' needs. And therefore, on the right, we get to see the assessments provided by our users. When they have gathered information, we get to see that this tool can be used for something else that only forests or only land use management. It can also be used for air quality, which is something that I'm going to refer to just now. And as I said earlier, you can select the map of or your area of interest, and you can preload other data sets that you have worked with according to different coordinates, and then you can analyze. For example, we have these data sets that have been preloaded, and they are a WRI template, and therefore you are allowed to create charts and tables, or you are able to know the exact amount of trees that were brought down or cut down. And also you can know if data sets are according to top quality requirements, and also you can share this, and this is the simplest way for you to share this with your audiences. And also you can open this information, share it, and therefore you can make better decisions. Information and hard data-based decisions can be made based on these methodologies. And also, for us to use this tool, it is not necessary that we rely on high infrastructure. The only thing you need to do is to rely on an ArcGIS online account, either a public account, which is for free, but also there are organization and corporation accounts. There are some limitations in terms of being this totally free, or that if they belong to a corporation. But at the end of the day, we have a template that is readily available to all of you once you complete some tutorial courses that are offered in 10-minute videos, and you can shape your own data and fill in your own information. The only thing that you have to consider is that they have to be in the following formats for this vectorial data. And the hardest work here, of course, is to gather all the data in the proper formats. But once you have prepared your data sets, which is something that often happens in this data, the world of data, that you have to prepare the database. But in this case, you have the tool to view all this in one single place through a very dynamic tool that is ready to be shared. And as I said earlier, we offer tutorial courses and we have guidelines that will guide you through the step-by-step of a platform, your customized platform creation. And I want to, once again, thanks to ArcGIS Online Technology that belongs to ESRI. This serves for us to gather information regarding the latest trends in terms of sustainability and spatial data, for us to have much more robust analysis to provide to our audiences. And one more thing is that in MapBuilder, we do not storage your data. It is you yourselves who store your own data. So the only thing is that you need to rely on enough capacity to store the data that you are going to combine with this application. And all this is a triangle that we need to talk about now, because we have talked about map building, resource watch, and the collaboration between the two of them. And for us to address the needs of our users, for example, if they have the opportunity to compare data at a global level, they might want to do analysis at a specific local area, and this is what MapBuilder will be good for. And recently we have included some of the analysis that are available from a Resource Watch, now available from MapBuilder. MapBuilder project is undergoing transition, and this is now that we are not only going to have data regarding forest and Forest Watch, but in this case, we are going to have much more integrated data related to land use and air quality. And practically, we have an air quality data set. And this is something that you get to see. And based on this, you can view, or this is what we get to view at this specific screen. And this is for us to bring our analysis to another level, which is much more robust and easy to analyze. And this is for you, since you are our allies, and we have a common objective, which is monitoring what's occurring in our planet in order to make better decisions for sustainable development. And next, I just want to share with you some use cases, since we are undergoing transition in order to be able to bring in some other types of information into MapBuilder. Currently, I don't have a use case specifically that I have to show you, but I can tell you how this is used. Here we get to see the template for different objectives for us to understand how we can view local data when combined with a great library of open source data. Like, for example, here we have MapBuilder specifically for early alerts for mega projects at Colombia. This earlier, it used to be an a platform that would identify threatened territories in the country, and it would serve to determine what areas are good for preservation or need to be preserved, and also to send alerts. Now, it sends alerts to the different communities, and it has an initiative from a non-government organization to add information in regards to how all these actions can largely impact the different ecosystems of the different communities. And based on information, visualization, and other types of data that have been uploaded, these are local data sets that have been combined with the data sets that are there for analysis offered by WRI, another project which is independent. In this case, this is data gathering for indigenous land in Paraguay. Oftentimes, we do not rely on enough information or data or regarding this specific sustainability topics. What they did was to visualize, to make visible everything related to these indigenous areas through these websites, and therefore by doing this they are able to offer these views or visualization to stakeholders about specific territories that are inhabited by indigenous people, with all the information regarding forests, forest fires, and other conditions that in this case are open thanks to WRI data, but now linked to very local specific data according to what this organization has gathered. And in this case, you can see that this can be customized according to a specific context and not only to the general context and global context. And also from Global Forest Watch, this is a use case from the Amazon. And this was supported, well, it was a collaboration, a very close collaboration with WRI, and there was support from other associations to, or in this case, Noor Numa, to take care of preserved areas at Suriname. And in this specific case, the community leaders are using this platform to understand and supervise the impact of deforestation, as in this case would be caused by mining and other industries, and based on this, be able to make better decisions regarding land governance. We are hoping and expecting that under these new collaborations that we are having with Resource Watch, we are going to have other community data included into Global Forest Watch regarding also air quality and how their own applications can be customized and created. And it is going to be a pleasure for us to accompany you in the process of creating your own tools. And also we have this product. We want to stress out that this product is here to improve your own work. And we very soon, I'm sure, are going to be able to show cases of success. And also we have this way of visualization for those free accounts. And all, the only thing to have a free account, it is that you fill a format. And if you are interested, we would love to see you attending our webinars. And there you're going to get a learning in terms of how to create your customized platform. Is going to be very simple. Now we rely on a very friendly questionnaire that you have to fill in, and you will see that there are many customization opportunities, what type of data sets you have to bring in, the titles, the language in which these are available, or MapBuilder is available. So in this case, what we want to do is to facilitate the process for you to continue to create your own visualization tools, and then you can open this information to your own audiences. And with this, we expect to be able to have a much more use cases where we can collaborate and we can continue to feed information, and therefore to continue to hold the conversation regarding sustainability in the whole planet. If you want further information, this is our contact information, both Kristine and mine, and also more information where we have other tutorial videos, as well as more information regarding your customized applications, as well as your own maps. And once again, I encourage you to, if you are interested in learning more about MapBuilder, next August 18, we are going to launch and release this new format for you, or questionnaire, to fill in so you can have your own maps. Thank you, Kristine. Thank you, Nancy, for this very good introduction about Resource Watch and MapBuilder. Now we're going to have an exchange of questions and answer, and we are going to have Sergio Baldit leading this. Hello, everybody. Hello, Ceci. Thank you for the invitation. I have a couple of questions for both Christina and Nancy that I think will allow us to get to learn more about what they have introduced. Well, first, there's a question asked by Florencio from our audience, and I think it is very important that we open with this question. Are these tools for free, or is there a fee we have to pay for them? Kristine or Nancy?
Yeah, I can answer that. So Resource Watch is completely free and open source. All of the code underlying Resource Watch is available and documented online. Like I said, we also have our GitHubs for how we process the data, but accessing the data and the platform is completely free. For MapBuilder, the tool itself is free. However, as Nancy was saying, for storing your data, it's best to use Esri's ArcGIS Online. And there's two types of accounts that you can have. One is a free account that does have some limitations in terms of the size of data sets that you can store and map and the types of data that you can have. It's easiest with vector data for the free account. Then there's a paid account through ArcGIS Online's organizational accounts, and those give you just more space and larger data sets that you can upload. So our homepage for MapBuilder will detail the differences in those accounts, but in short, both MapBuilder and Resource Watch are free and open source. And if you want more features for your local data, then you can pay for the organizational accounts from ArcGIS Online.
We have another question regarding Resource Watch specifically, and this is what advantages are offered if we view data from Resource Watch compared to addressing directly NASA data sets and break them down. What would be the advantage?
Yeah, I would say there are a couple advantages for Resource Watch. We have the data already visualized for you and aggregated to time spans that make sense. This was done in help from the WRI air quality team. But Resource Watch puts a lot of work into pre-processing the data sets so they can be easily searchable and visualized on the platform. We also provide metadata for the data sets where we go through and read the technical documentation from the data sets and convert it to a more easy to understand version where you can get quick information about the data set, such as the spatial resolution, the overview of the data set, who's the data provider. And lastly, I'll also say that I did not highlight this in the presentation as much, but using Resource Watch, you can actually overlay a number of data layers together on the map so you can do some kind of quick investigation. For example, we have population data sets on Resource Watch, as well as power plant data sets and other sources of air pollution that you can overlay with our various air quality data sets to kind of check out what's going on in near real time. And to do that, you can just add multiple layers to the map, and it's pretty easy. I've actually put together some of them, and I'll paste this link in the chat so you can explore some of the data sets that we have that you can overlay. If you wanted to dig into the data sets more, I would encourage users to either download the data from the source or to investigate the links that we shared in the presentation as well.
Thank you very much. Here I have a couple of questions that are related, and these are both for Kristine. And if the question is, if Resource Watch can be used for subnational analysis regarding air quality. And there is another similar question made by Ismael, and it says if it is possible to get forest information or forest change information at subnational levels from different years.
Yes, so Resource Watch is mainly a data discovery and visualization tool. So we do not have as much analysis capabilities from Resource Watch. That's why I linked to some of our underlying assets. However, MapBuilder is more designed for doing these type of analysis in your area of interest or in data layers that you upload. So as Nancy showed in the presentation, you can do some predetermined analysis using such as vector data sets from the data that you've uploaded to ArcGIS Online. In the air quality case, it could be like city boundaries or county boundaries to do this type of analysis. And that analysis is coded by the WRI teams that work on MapBuilder. So currently MapBuilder does feature a number of analysis available for forest data sets in particular, and we're working on adding more air quality ones as well. So that's how you can do subnational calculations on those data sets. But otherwise, you can access the raw data that Resource Watch pulls into.
Well, while we have Kristine back, I have a question that is related to what Kristine was telling us. And this relates to both Resource Watch and MapBuilder. And this question says or asks if we can include our own data.
Depender de los datos que tiene WRI. Y la segunda que me parece que está relacionada.
Or I think this is related if we include our own data, or what formats are there for MapBuilder. I can answer to these questions. Actually, I'm going to share a link to MapBuilder, which is very simple, very easy to use. It is so easy to share. And this is something that I did in a matter of minutes. And here you get to see all the data sets that have been preloaded and also others that are offered in the platform, which is called GIS, ArcGIS. And here to MapBuilder, you can bring your own data. The advantage of MapBuilder is that we have WRI preloaded data, and you can add this as an additional layer, and then you add your own data. And I'm going to share my screen back again. And this is what I just shared earlier with you. Here, I enabled air layers that were already available from ArcGIS or GIS. And here we activate the one which is available from Resource Watch. And here I can get and combine other data which are available and have been preloaded by WRI. And here you get to see tree cover loss in different years. And therefore you can adapt this to your own taste and upload your own data, and the forms by which is are available are vector. I'm going to share with you this data that I have already shared in my presentation, but once again, you have it readily available. And based on this, you can create your own customized map, and you can adapt it and then have it for specific regions or areas. And the idea is to bring more data coming from Resource Watch to MapBuilder, so you can have a much more robust analysis. And then you can have what you can do, what you can combine, you can change the way you view this, and then you can go for specific areas, run analysis, and so on. Well, and just to make a distinction here, you were telling us that MapBuilder brings data from Global Forest Watch and now specifically from Resource Watch for users to be able to integrate their own data sets and therefore have their customized analysis. Is there a way that either governments or local agents are able to add their local resources to the Resource Watch catalog? Is there a way to do that?
Hi, everyone. Yeah, sorry, I lost connection for a bit there. Yes, so the question of can you add your own data to Resource Watch? Right now, we're limited to data that is peer reviewed and has a published methodology. So for example, with the City AQ data set, that was a publication with WRI and NASA. So right now we are not taking any data sets without a peer reviewed and published methodology, but you can reach out to us about those data sets. But however, that is why we have joined forces with the MapBuilder team, where you can upload your data and create interactive web maps and embed them into websites or post them as their own web pages. So yeah, I don't know, Nancy, if you want to jump in as well.
Una de las grandes ventajas
One of the greatest advantages
entre MapBuilder y Resource Watch sería qué tipo de datos podemos
the Resource Watch and MapBuilder is that I can bring my data together to the data which is currently already existing. And then, like, for example, we have done with the Tecnológico de Monterrey. In this case, this is that their own data are there available for their customized use in terms of analysis or for analysis. I don't know, Sergio, if there is anything else that you want to add regarding this specific question. Well, I just would like to add very briefly, as Kristine said, these are our current policies so far, but we have heard that there are different groups that have the need to rely on catalogs that include other types of data. Here we are assessing from Data Lab the way to integrate and bring in this data. And if you want to bring your own data in, this can be analyzed in the near future. We can have conversations regarding how we can integrate those data to our catalog. And we have a last question over here. Jair is asking that he says that in MapBuilder, they have identified that when using the data, they have some mistakes regarding emission measurements. He's asking if data are corrected or if information is just uploaded as it gets. Well, the MapBuilder that I shared with you, it was made very quickly. And of course, these are data preloaded at our AirQo online. And these are data that you yourselves can correct if you consider that's convenient. And the data at Lands News, these are the ones available at AirQo. And also we have available at Climate. In this case, this is linked to Resource Watch. So WRI maps are the ones that are analyzed by our teams, and these are constantly updated. But what I showed on the screen was just an example. So you might have found errors, and this was just as a way of example. And the WRI and preloaded maps have been analyzed by our team in a very careful manner. Thank you for that question. And taking advantage of the 2 last minutes, I would like to ask a specific question in order to bring everything rounded up that includes our speakers and our attendees here. If there is a request you could make to the governments of the world regarding data, how could it be that local players and governments would support the available data regarding air quality? Thank you. Good morning, everybody. My name is Jair Carrillo, and I'm from Nuevo León Ministry of the Environment. We have worked with WRI initiatives regarding air quality, mostly for forecasting. And I think that this is a very useful tool for us to visualize and for people to rely on clearer perspectives regarding to air quality problems, Something that really supports visualization, I think, is that these are tools that we can share and teach others about this, because we have lots of initiatives, but then we lack technical support, or we other people don't have technical perspectives of all these matters, so they get confused, and therefore we are not allowed to have a better way to make this visible, to make these issues visible to general society or the community at large. So hopefully we are going to have more open data here in the state of Nuevo León in North Mexico, so people can be trained and then be offered better information to compare to what's on the web, because as you were saying, specifically here in Nuevo León, we have more than 50 or 100 teams working on air quality, but they do not have one single methodology to be able to rule out erroneous measurements. So relying on these types of tools will allow us to teach people about air quality and also about how to properly use the sensors by a citizen network. That's my contribution. Thank you. Thank you, Jair, very valuable. Oh, we will have to leave our Q&A session now, but I want to remind you that we have Resource Watch email where you can share with us more uncertainties and you can ask more questions. We want to thank Beatriz, Ceci, and the community of practice for having invited us to introduce these topics to us. And now we're giving the floor back. Thank you, everybody. Thank you for your participation. We want to thank our keynote speakers, and also Sergio for having moderated a Q&A. Now we are going to get back to our second section, which in this case, this is about local experience. Our first speaker is Richard. He is a data scientist working on co-initiatives, and he has worked on artificial intelligence as well as renewable energies. Richard, the floor is yours.
Thank you, Anna. And hello, everyone. My name is Sserunjogi Richard, a data scientist from AirQo, Makerere University. Today, I will be talking about the generation, visualization, and use of air quality data in the African context from the AirQo experience. First, I will give an overview of how air quality data is generated at AirQo, and then a brief on maybe why the air quality data is important, which visualization tools we use at AirQo, some visualization use cases, challenges that we face, and the implications and lessons that are learned from our experience interacting with these platforms and visualization tools. Yeah, so to start with, we'll go direct on how air quality data is generated at AirQo. But yeah, before I go into that, for members who might not have prior knowledge about AirQo, AirQo is an initiative from Makerere University that aims to improve urban air quality in African cities. Yes, our vision is to ensure that we have clean air for all African cities. And to do that, we develop low-cost monitors and deploy them in different suburban places in different cities in Africa. Currently, our presence is mainly in Uganda, but we're expanding to other African cities. So we develop low-cost monitors, what you see here in the diagram. These are locally built low-cost monitors here in Kampala. We built them, we developed them to be able to withstand all the environmental aspects that are related to Sub-Saharan Africa. Yeah, these are then deployed either statically or on a mobile monitor, and data from these low-cost monitors is transmitted to our cloud platform, which is then visualized or analyzed to make insights and make decisions regarding the health implications or the policy intervention that needs to be done by the different stakeholders. So what you see here, this is how a low-cost AirQo monitor looks like. Then we collocate them with reference grid monitors, like what you see in this visual. And then we calibrate them to ensure that they have their readings are close as possible to the readings from the reference grid monitors. That's in a nutshell how air quality data is generated from AirQo devices. Maybe just add on is that these devices measure particulate matter, that is PM2.5 and PM10 primarily, with an effective range of 0 to 500 micrograms per cubic meter. Okay, perfect. So why do we visualize, or why air quality data visualization is important in the context of AirQo is that we collect a lot of data from these devices. These devices send in data after like 90 seconds. So visualization helps us to really understand the trends and patterns within these air quality data sets. And it also simplifies the data by giving a full picture of the parameters that are scoped, leading to efficient decision makings, and also helps to unify an interpretation of what different air quality readings might refer to. And additionally, this is good for data exploration if you are generating scientific insights, and generating scientific insights, and also for communication and public awareness of the air quality issues. So I will go to the local experiences and challenges in how we use the visualization platforms. I will start with the current landscape current landscape of the visualization aspects we deal with at AirQo. The first aspect may be that we take to be standard is the air quality index, which is widely used in air quality visualization to ensure that all the different audiences have a standard way of understanding what these readings from the air quality mean. We basically adopted the US EPA air quality index simply because currently, I think in Uganda, we didn't have a locally developed air quality index yet, but we are in the process as a country, I think, in developing these air quality standards and air quality indices. So this is the baseline for all the visualizations and the presentation of different visualizations that we share, or the visuals that we do for communications, for insights, even if it's research. We basically try to communicate them based on the air quality index. So to ensure that we get this visualization, there are specific tools, visualization tools we use at AirQo, and these are widely, I think, used in the entire maybe scientific and academic and in the industry sector. Packages that help us to visualize the air quality. Mostly we use Python packages. That is Matplotlib. Most of you, I think, might be aware of it. Plotly, in case we need interactive visualizations, Seaborn, data prep for data exploration and understanding the distributions of the data and to create generic reports. Excel comes in handy. It's a basic tool, but we use it in some instances. Also we use OpenAir package from R package to do air quality analysis, especially in cases where we want to visualize temporal trends or the daily readings of the air quality.
2 minutes, please.
We also used ArcGIS for spatial visualization and GeoPandas plus Forium. And D3, for those who might know about it, it also is another JavaScript library that helps in visualizing, not only air quality data, but visualizing numerical data. And mostly we use Jupyter notebooks in case we need to come up with insights and maybe understanding relationship between different air quality readings and other parameters. Now when from these tools, we found out that using those tools, it's not easier for the non-technical team to easily use them. So from experience and interaction with different stakeholders and users, due to the challenges and the technical work that was required to generate simple visuals, we developed bespoke AirQo digital platforms that helps to make visualization easily accessible to different users, both in real time and in other instances. So we developed several digital platforms to visualize the air quality in real time. We have a map which can be accessed on AirQo website or on AirQo platform, which shows real-time readings of different air quality pollutants. With this scale, the colors indicating the different air quality categories. The mobile app can be basically downloaded by anyone, wherever they are. And it can be installed on your mobile phone for you to be able to get real-time readings, forecasts, what the pollution will be, and also setting favorites in case you need, you have favorite locations where you need to monitor or get informed about the air quality in those locations, and also to give some guidance on maybe what actions to take in case the air quality exceeds a particular threshold. I've talked about the mobile app, which can be downloaded from Google Play Store or Apple Store. It has a lot of features, the insights viewing the historical readings for the last couple of days, and also the forecasts. And this numerical presentation of what the air quality is to ensure that people, at least all users, are able to get and visualize the air quality in areas that matter to them. I think from the mobile app, we went ahead because mobile apps are kind of limited. We went ahead and developed a custom platform that can be used by non-expert users to generate visuals regarding the air quality in the different regions or regions of interests. Users can come and select the areas of their interest from this section, and then the mean daily averages are reported, the exceedances over the past 28 days, and all of these can be customizable. And still users can create their own charts which they can download and export and maybe include in a report or in a policy brief that they are working on. And this platform usually, okay, yeah, this platform usually can also, in case you can't get the necessary visualization from it, it has capabilities to export data, and different organizations, the way we made it, can join, add their data, air quality data, and they can have their custom interfaces where they can visualize all the air quality that they are interested in. Yeah, so
time's up. Please, could you please conclude?
Okay, in a few minutes, I'll just maybe talk about, okay, the use cases from our experience. We know that air quality varies in time and space. So these were just sample use cases showing the diurnal variations of different air quality readings, which can be generated. So I'll just go quickly through these. Yeah, these are still other temporal variations of air quality that can be generated. This is an example of how we use open air package in R to generate calendar plots, just to ensure you can have a clear or longer term view of what air quality is. Then visualizing the percentage increases and decreases in air quality data. These are all visualizations that you can be generated from the platform. I already talked about the exceedances. These are key for policy or people who are concerned with making interventions to know which areas are of high concern. And then, okay, quickly, I'll just this for visualizing spatial data, we use ArcGIS. I mentioned about it, heat maps, leaflets, etc. But the overall goal is to ensure that we see, we can be able to get and know the hotspots of where the pollution is. This is just an example of how we visualized readings from mobile monitors.
Richard, sorry, but we have another presentation. So could you please just conclude?
Okay, yeah, let me conclude maybe in 2 minutes. Just a few challenges maybe that we experience is that making visuals easily understandable by all people. I think from diverse background is challenge. We have challenges of data quality. Some sensors sometimes goes off, and then comparisons of these visuals is quite hard. And visualizing uncertainties in predictions is a challenge, and also better representations of interactive geospatial data. Yeah, the lessons basically is just maybe I'll pick out one, is to ensure that you keep getting user feedback and user feedback on the visuals you give them, and yeah, you have a clear audience of clear knowledge of the audience and what they need the visualizations for. Thank you all. I think you can reach out to us, AirQo project, also reach for more information. Yeah, thank you for the opportunity.
Muchas gracias, Richard, por compartirnos esto desde África.
Thank you, Richard, for having shared with us all this from Africa. Now, also, of course, we're going to have questions from our key speakers and from the audience, so they can ask you directly. And lastly, we have our panelists from the Meteorological Agency in Ghana. Victoria, the floor is yours. Thank you very much.
All right, so I'm presenting on challenges that are faced with the generation of air quality data and also visualization of data. Victoria Owusu, a meteorologist at the Ghana Meteorological Agency, and also a PhD student at the Kwame Nkrumah University of Science and Technology, Ghana. So this is going to be my outline for the presentation, introduction to the way forward. Now, for the introduction, Ghana has been experiencing rapid economic growth in the last few years, which has raised the living standards of people in Accra, especially, which happens to be the most populated region in Ghana. Now, the number of vehicles owned as a result of that has increased, leading to worsening air quality, especially in the capital city. According to the WHO, mean concentrations of PM 2.5 in Ghana was around 31.1 micrograms per meter cube. However, this is an exceedance of the WHO standards of 10 micrograms per meter cubes. From a research paper, which was published by Adonko and Mahami 2020, they give an indication of the growing poor air quality in Ghana as a result of the PM 2.5 concentrations. And then from the paper, it was concluded that poor air quality has repercussions on our health. But due to this effect, sadly, we lack meaningful open source air quality data, which hinders actionable steps targeted at reducing air pollution. And also for research, we are very limited as in terms of research and then mitigation plans. So they need to study the effects of it. And then also for access to open source air quality data. Now for some work done for my, I'll use my thesis as the case study here, since most of my work has been on air quality, it's just basically on my PhD studies. So for some of the work done, looking at the seasonal variation in terms of meteorological effects on PM. So I use the 4 local sensor data from Accra here, and also there's a beta attenuation monitor, which is the B, the plot number labeled B, situated at the US Embassy in Accra. I tried to find out the PM concentrations seasonally. So during winter, concentrations were higher in winter, but then least concentrations for both the BAM instrument and then the purple sensors. That is the A figure. Least concentrations were recorded in fall, during fall season. Summer is the where we record the major rainy season in Ghana, and then winter is the Harmattan season. That is from December to February. So obviously winter for Harmattan, the northeast trade winds coming in has an effect on the quality of air we breathe in. So I use that data to also calculate the air quality index based on the seasons. And then from the concentrations, it was shown that for the air quality index, winter had the poorest air quality in Accra for both the PM local sensors and then the BAM instruments, which is the D figure. And then the least concentration was which gave a better or a good air quality was in fall, which recorded the least concentration. Now that's a separate project I'm doing. So for the Canary Alert, another project I'm doing towards the Canary Alert is to develop a bias correction tool for the GeoCF model. But in developing that, I would have to validate the model first to know if there's a bias or not. So this is a validation, one of the validation plots for the BAM instruments at the US Embassy. I compared that to the GeoCF model at the same grade. And then this is the figure I'm getting. The mean for the BAM instruments was around 23.6 micrograms per meter cube. And that of the GEOS was 18.2 micrograms per meter cube. From the plot, it's clearly shown that the GEOS, which is in the orange color, clearly gives out or replicates the linear pattern shown by the observation data or the ground-based data, which is the blue color. But then there are biases. As it gets to some point, the GEOS lags a bit behind in terms of concentration behind the observation data. That's the BAM instrument. So there's a need to correct that bias. But then I'm working together with Christophe, Emma, and then Dan Westerville to we're trying to create a bias correction tool where we would have to input initial condition sets and then run the tool for bias correction. So it gives out a bias correction method before we can, we'll be able to issue forecasts for policy making and then decision taking, which results in policy making. Now, during this work, I faced some challenges along the way, which I would want to talk about. Now, in downloading the data sets, access to reliable internet connection became a problem, especially with the NetCDF file from the GeoCF model. When the internet is interrupted, sometimes you have to start all over again. And also interruption of power supply. Power could go off anytime. If power goes off, internet goes off, which affects the downloads, thereby delaying the work. Now, availability of data, that one, under that, I'll talk about baseline data. There's no baseline data to inform us as to how in the past air quality was, or the air quality data to inform us on the quality of air that we breathe then, to be able to analyze what is happening today, to determine whether it has improved or not. There's no baseline data. And then the sparse data network. Currently, the data network is basically or mostly over Accra, leaving the other regions, like they have the sparse data network over the other regions. Even in Accra, where we now have quite a number of local sensors, there's still some gap that needs to be filled. Now, lack of monitoring of key gaseous pollutants. Mostly the local sensors measure PM 2.5 and then PM 10. But then we don't have monitoring, we don't have instruments that monitor the other criteria pollutants such as carbon monoxide, SO2, NOx, and then ozone. And then also data acquisition. One problem I face for the GeoCF, you can't download like a bulk, you can't do a bulk download. In that the time steps is very limited. That's about 744 time steps. So you could only download for a month. But then, so supposing that you would want to download for a year or two, you would have to download each month separately. I didn't know how to go about that, so I had to do the manual way, doing it monthly before I could get the data, and then use tools to merge the data so I could work on the data. Now, there are also portal challenges associated with downloading the data online, because sometimes the servers might go off and also, and then the portals are sometimes not user-friendly. You have to maneuver your way out so you get to where you would be able to download the data. Now, the spatial and temporal resolution of data. From Ghana Met, for my first analysis that I did, that is under the seasonal variation, Ghana Met data gave me, what I got was the temporal resolution was only daily, whilst the purple layer coming in was hourly. So I had to convert it to daily. I couldn't get hourly data, which could have given us a very good average as to what is going on the ground. And then model or satellite data, sometimes the spatial resolution, for the spatial resolution, I'd have to regrade it to the specific point source where the instrument is before doing the validation analysis. Now, quality controlling of the data. Most of the data from Ghana Met has missing data. There are so many gaps in the missing data and data inconsistency. From purple layer, sometimes due to internet access, one might place purple layer at a certain location, but internet might be a problem. So they will have to move it to a different location, thereby creating a very inconsistency, creating inconsistency in the data set. Now for challenges, as to with respect to data processing and visualization, now we would have to be skillful as in when it comes to statistical tools such as Python, R, CDO, Excel. At least you would have to have a knowledge of one of them. But then with our case, or coming from an African background, these tools sometimes seem to be a bit strange because we're not used to that. We might basically go with the Excel, which, okay, that one might be easier. But then with Excel too, it's difficult to analyze most data sets, especially if it's in NCD and NetCDF format or HDF or any other format. And then also it takes quite a while for Excel to execute a program or a code in Excel. So basically Python, R, CDO. So the challenge I encountered with that is that Even though I'm very comfortable with R, sometimes some of the codes I would have to do it in Python because it's easier. So I would have to learn that within the shortest possible time. Sometimes I use CDO, which sometimes becomes an advantage because I'm conversant with all. So I could use CDO to check to do the seasons and calculate the average for the seasons, especially when it comes to NetCDF files, and then use Python, use CDO to convert to CSV files, and then use R or Python to do the statistical analysis on them. And then there's complexity of tools and packages. Packages associated with these statistical tools, such as Python, R. Now we have packages that does the manipulation of data, like Pandas, NumPy. You'd have to understand how these work before you could use them. So sometimes it becomes a bit of a challenge. If you get somewhere and you get stuck, you have to be able to know your way about it before you're able to run the data. This might delay whatever work you're doing. And also some visualization tools. One major problem I encountered was during my analysis on the GeoCF, I tried to look at, there were periods where there were spikes in PM 2.5. So in discussions with Christoph, I was supposed to do a spatial plot of CO. That is, and we wanted to check biomass burning emission effect on PM over Accra, PM 2.5 over Accra. Now, using the Python, RGDAO, the package RGDAO gave me so much errors. I couldn't download it and I couldn't install it on my, using Conda to install it on Spider. So it became a problem. I ran into so many errors. Then I had to switch to R. So sometimes some of the tools or packages becomes problems for us to use. Then data formats such as NetCDF, HDF files. If you're not too conversant with these files, it tends to delay the whatever program or whatever projects you're trying to do. Now you need to understand how NetCDF files work, how HDF files work before you are able to work on them or do any analysis on them. So for me, for instance, I'm conversant with CSV files. So when I get an SCDF file, if I'm not doing a spatial plot and just doing statistical analysis on them, I'll prefer to convert it to CSV file. But when it comes to HDF, NetCDF to CSV is quite easy. I could use CDO easily to do that. But HDF files becomes a problem because I'm not too conversant with that. So I hardly work with HDF files. Now the way forward, improving data network, that is improving sensors, local sensors across the country, not only in Accra, but taking them to other places, could help us gain baseline data for future analysis. Also capacity building in the use of statistical tools, programming languages and all. We need the capacity, we need to build capacity in that area as well. And then also there's the need for user-friendly portals for data downloading, which makes it easy to access data online and then download data easily. Now, before you could do any analysis, when it comes to air quality, climate, or any weather analysis, I think that one should be statistically inclined. So if you are not statistically inclined, you might not be able to understand what exactly the output you might be expecting at the end of the day. So that becomes a problem or a challenge. So the way forward, if we could abreast ourselves with statistics, the basic statistics that we do in the various schools, and then creativity and flexibility with most of the visualization tools would help us a lot. So thank you very much. And then that will be the end of my presentation.
Muchas gracias de nuevo, Victoria.
Thank you. Thank you, Victoria, for having shared with us your presentation from Ghana. Unfortunately, and due to time limitations, we will have no time for a Q&A session. Thank you, everybody. Thank you. We want to thank Sergio for having been our moderator. Hopefully these sessions have been of your interest, and we are going to continue to keep in touch with our community of practice to continue to increase our community.